Hi, this is Dr. Jed, and today's lesson is on the product rule. We'll talk a little bit about it, how to get the idea from a function we already know. Then I'll just give you the rule. You could derive it using limits, but I think, honestly, we're best served by just doing some examples and seeing how it works. So first, though, the idea. I'm going to take x to the 8th, which you should know how to take the derivative of it. So, what do? You take the 8, you get x to the 7. That's the derivative, and if that were it, we'd be done. But I want to actually notice that x to the 8th is really x to the 3rd times x to the 5th. So any product row we create better work with these two functions. So f is x to the 3rd, g is x to the 5th. So the first thing you might think is, well, if this is a product, the derivative of the product should be right. So let's take the derivatives of each of these. This is 3x squared. This is 5x to the 4th. And if you multiply these, you get 15x to the 6th, and that's not this. So the derivative of f times g is not f prime times g prime. It's something else. Let's see. Well, look at this for a while. See if you can see the pattern. Okay. Hopefully you saw something, or at least now you're thinking about it. What I key into here is there's x to the 7th right here. How do I create x to the 7th? I see it, well, if I make these two multiply together, I make an x to the 7th. If these two multiply together, I get x to the 7th. And honestly, there are 3 of them there are 5 of them there. If I add it together, I get 8x to the 7th. This is f prime x g plus g prime x f. Or f g prime plus g f prime, or however you want to write it. That's the product rule. In fact, here it is. Now, later in some other sections, we'll talk about what to do if these are not necessarily even functions, but say implicit functions, or something else. But the product rule will always work this way, and there are a couple important points to notice. Plus here means we can interchange these two terms without problem. It's commutative. Times in each of those means each of those terms is commutative. So the ordering could go somewhere else like this. F g prime plus f prime g. There are a whole bunch of ways to reorder it. It doesn't matter which one you use, but this rule itself is the rule to use. So let's do some examples. My first is the derivative of x times e to the x. And in this case, it's obvious which one is f and which is g, or at least what the two functions are. There's f, there's g. So what I usually do here is I would write f equals x, g is e to the x. Notice I've lost the parentheses x. This is sort of a shorthand notation, so some of the niceties we just kind of get rid of because we don't need them as much. I need the derivative of each of these. I'm actually going to do the derivative of e to the x first because we know it. It's e to the x. Now the derivative of x. You could use the power rule, you could use the line rule. However you do it, it's 1. So the derivative is going to be f times g prime plus g times f prime. Or it's going to be x times e to the x plus e to the x times 1. Now that's right, but there are a couple things you might want to do. This times 1 here is a little awkward. We can get rid of it. Times 1 doesn't mean anything. Then there's an e to the x here, and e to the x here, and e to the x's are a little bit messy, so I'm going to factor them out. And when I do, I have x plus how many e to the x's here? 1. So x plus 1 times e to the x is a better answer, but this one up here is correct. How about this one? Well, this is my f. So I'll write it right below. F is square root of x plus 6, and g is 3x minus 2. So f prime, take the derivative of that. The derivative of that is, okay, what is it? Well, the 6 is a constant. You can think of the 6 as a line with a 0 slope, just at the height 6. So its derivative is 0. Square root of x, we've done that one before. That's 1 over 2 square root of x. There are other ways to write it, but that's true. G prime, that's a line. The derivative of the line is the slope. So we get f times g prime plus g times f prime. So we get f times g prime. So square root of x plus 6 all times 3 plus g times f prime. This is messy, but let's multiply everything through. 3 square root of x's plus 18 plus, well, this times that, so we have 3x over 2 square root of x minus 2 over 2 square root of x. Now, honestly, you probably shouldn't leave it like this because some things will simplify. For example, look at these 2's. We can get rid of that. Here, x on top, square root of x on the bottom, we'll partially cancel, leaving square root of x. So we have 3 square root of x's, 3 square root of x's makes 6 square root of x's plus 18 plus, minus, is that minus? Yes, it is minus. Minus 1 over square root of x. It's something you have to practice, but once you do, it works very well. Until next time, this is Dr. Jed.